So in this video, we're going to talk about topic 3.2, which is implicit differentiation. Your essential question is, how do you use implicit differentiation? And your I can statement is, I can find the derivative implicitly. So on the left-hand column is a little bit of a hint of when you actually use implicit differentiation. So when the equation is not just y equals something, you never solve for y, instead use implicit differentiation. So let's read through what implicit and explicit are. So generally we have been working with functions written explicit form, meaning that y is expressed as a function of x. So this right here is an example of explicit form where it's y equals something, and everything on the right side are all in terms of x. However, some functions are difficult or impossible to write in explicit form. Instead, they are left in implicit form, meaning that x and y are written together in an expression without solving for a single variable. So if you look at this second one here, the x and y are both on the same sides, and x times y would make it difficult to write as a single, as y equals. So one of our key questions is, what does it mean to find a derivative? This key question is often misunderstood because we only have been working with explicitly written functions so far. If given an equation involving y, asking to find the derivative is equivalent to finding or solving for dy dx. So you want to remember that the derivative of y is dy dx, which means the derivative of y with respect to x. Writing dy dx indicates that we are taking the derivative of y with respect to x. Taking the derivative of an expression involving y requires the same rules we use for expressions with x. Derivatives always require the chain rule. So doing the dy dx part is kind of like doing the chain rule. So we're going to differentiate with respect to x. So if we notice this one right here in A, when we take the derivative of of x cubed, we would end up with 3x squared. And then because we have an x, we would say dx, because it's the derivative of x with respect to x. Well, this part here disappears because dx is just 1. So we would say 3x squared. When we're going to take the derivative of y cubed with respect to x, it would be 3y squared dy dx. Because what's happening is you're taking the derivative of the inner function, which is just a y, and that's written as dy dx. So it's like using the chain rule all the time. If I was going to do c here, the derivative of x would be 1 dx dx plus 3 dy dx. But the dx reduces to 1, so we just have 1 plus 3 dy dx. If I look at D, notice I've got a product rule going on. So I've got my red and I've got my green function. So I'm going to take the derivative of my red, which would be 1 dx dx, leave my green function alone, which is y squared, put a plus sign, and then I'm going to leave my red function alone, which is just x, and then take the derivative of my y function, which is going to be 2y dy dx. And I could simplify that, make it look just a little nicer. The dx turns into 1, so you have 1 y squared, or just y squared, plus 2xy dy dx.